All right, let's pull back the curtain on one of the most talked about pieces of tech out there, generative AI. I mean, it seriously feels like magic, right? But what we're going to see is that behind that curtain, there's this really fascinating process of logic, data, and yeah, a whole lot of math. So let's just dive right in and see how this stuff really works. So this is the big question, isn't it? We're going to follow the entire journey, from the moment you type in a simple prompt, all the way to this complex, totally original thing it creates. How in the world does a machine bridge that gap between our human language and, say, a piece of digital art? Well, let's find out.
The very first step in all of this is translation. Before an AI can think or create or do anything cool, it has to understand our world. And to do that, it has to convert everything, every word, every picture, every sound, into the only language it really speaks. And that's the language of numbers.
That language is all about something called vector embeddings. It sounds complicated, but think of it like this. Every single concept you can imagine, the word joy, a photo of a dog, the sound of rain, it all gets converted into a unique list of numbers. That list is called a vector. You can kind of picture it as a super specific address for that one idea inside this enormous digital library of concepts.
And this visual just lays it out perfectly. Over on the left, you've got all these different kinds of data. An image, a document, an audio file. They each get fed into this AI component, often called a transformer, which is basically a universal translator. Its only job is to turn that input into a totally unique numerical fingerprint, a vector, which you can see all neatly organized there on the right. Okay, so once everything is translated into this universal language of numbers, where does the actual thinking happen? Well, that takes us to the next stop on our tour, inside the AI brain itself. We're talking about the foundation model. And here it is, the AI's brain, the foundation model. This is the engine. It's been trained on an absolutely mind-boggling amount of data, text, pictures, code, you name it. And its job is to learn the patterns and the relationships between all of those different numerical vectors. It's the thing that learns to connect the vector for puppy to the vectors for cute and fluffy and bark.
But how does it really get context? I mean, if you say the bank of the river, how does it know you're not talking about a place to get money? The secret is in this surprisingly elegant little mechanism, and it's called self-attention.
This is a perfect way to describe self-attention. Just think of it like a spotlight. As the model is going through a sentence, it's not just looking at one word at a time in a straight line. No way. It's constantly shining that spotlight back and forth across the entire sentence, trying to figure out which other words are most important for understanding the word it's on right now. So, in our example, it would quickly learn that the word river is the key piece of context for the word bank. Simple as that.
And that leads us to a really crucial insight. When an AI is generating text, it's not understanding things the way you and I do. It's actually playing a very, very sophisticated guessing game. After using that attention spotlight to get the context, the model just predicts the most statistically probable next word. And then it adds that word to the sentence and does it again and again and again until a whole coherent thought is formed. Okay, so we've covered how an AI can understand and write language. But what about making images? Well, that's a whole different ballgame, and it starts not with a blank canvas, but with complete and total chaos. To really get the breakthrough here, you have to look at the old way versus the new way. The older models, they tried to generate an image in one single giant leap, and this often led to some pretty bizarre mistakes, like people with 6 fingers. But the new approach, used by what we call diffusion models, is so much smarter. It's all about iterative refinement, building the image step by step and correcting itself along the way.
The big idea is just beautiful in its simplicity. Instead of starting with a blank slate, the model starts with a screen full of random digital noise, like old-school TV static. Then, guided by your text prompt, it begins to slowly, carefully carve away that noise bit by bit. It's just like a sculptor revealing a statue that was hidden inside a block of marble the whole time.
So here's the play-by-play of how that works. It starts with an image of pure random noise. Then, with your text prompt as its guide, let's say an astronaut riding a horse, the AI just removes a tiny bit of that noise, and then it does it again and again. It repeats this denoising step hundreds, maybe even thousands of times. And with every single pass, the image gets a little bit clearer, a little more refined, until finally this incredible masterpiece emerges from what was once just static. So,
We've looked at all the individual pieces, right? Turning words into numbers, understanding context, carving images out of pure noise. Now let's zoom out and see how this entire system works together from start to finish.
This diagram puts the entire assembly line together. And I know it looks a little complex, but we've actually already talked about all the key stages. On the far left, you have your input, your question. That goes into the embedding model to get turned into numbers. Those numbers are stored and searched in what's called a vector database. And finally, all that numerical context gets passed to the large language model on the right, the brain, which then generates the final output, whether that's an answer to your question or a brand new image.
So let's just simplify that entire flow one last time, because it's really a three-step dance. First, you translate. Your question gets turned into numbers. Second, you find context. The system finds a bunch of other numbers that are related to your question. And third, you create. The AI brain takes all those numbers and either predicts the most likely next words for an answer, or it carves away noise to create an image. That's the core loop, right there.
And that's really how generative AI works. It's this remarkable fusion of data translation, incredible pattern recognition, and this process of iterative creation. And it really just leaves us with this one fascinating question, right? Now that we've built machines that can not only understand our world in this deeply numerical way, but also generate totally new versions of it, what new frontiers will they help us explore next?